Today we're going to look at a standalone day that helps us find the area of various polygons. So we'll look at pentagons, hexagons, octagons, decagons, things like that. You will need your calculators, so please be taking those out. And the sub should also be giving you a packet that has this slide on the top of it. Now, if you turn your calculator on and go to a calculator page, we need it to say DEG in the top right. Notice mine says RAD. So if yours happens to say RAD, click RAD with the cursor and it'll switch to DEG. We want it to be in degree mode. In Algebra 2 next year, you'll work with radian mode, which is just a different unit of measure for angles, but in geometry we work with degrees. Now, degrees versus radians only matters when you work with sine, cosine, and tangent, our SOHCAHTOA, which we will be working with today. That's why we need to have that. So first, in a polygon, a couple vocab things first. The apothem is a perpendicular line segment that goes from the center of the polygon to the midpoint of its side. So an example of an apothem here would be this green segment, and it forms a right angle. So again, this would be an apothem. So some properties about it is it does bisect the sides because it's going to the midpoint, because midpoint implies two congruent segments. So these two parts end up being congruent. And it bisects the center angle that's created by two radii. So what we're always going to do is we're going to just draw in one of the radii. So this is considered our radius here. And the reason we will do that is because it then forms a right triangle. And our general strategy of what we're going to do here is we're going to find the area of one of those right triangles, and then we'll use that to find the area of the entire polygon. And we have down on the bottom there that general idea. So we'll always draw in one of the radii and an apothem, make a right triangle. We'll find the area of the right triangle. Remember, area of a triangle is just 1/2 base of the triangle times height of the triangle. And then we'll just multiply by how many triangles of that size are actually in our figure. So the first one we're going to look at is an octagon. Octagon has 8 sides, and we've got a radius of 20 inches. So first thing we'll always do is let's draw in an apothem, which forms a right angle, and we'll draw in a radius. Step 2 is we want to figure out how many triangles of that size will fill up the entire octagon. Well, you would have 2 of these triangles on each side, because if we wanted, we could have drawn the triangle this way, and that would have been 2 of them there. So 2 of them on each side. An octagon has 8 sides altogether, so therefore we should have 16 triangles altogether. And I would strongly suggest you just list that somewhere on your paper right at the start, because we're going to do a whole bunch of calculations, and we'll want to remember at the end of our calculations that there's 16 of these triangles in the whole figure. Well, they told us the radius is 20. So let's go ahead and label that in our picture. The radius goes from the center to one of the vertices. To find the area of this right triangle, we need the base and the height, the 2 parts that make the right angle. So let's pick some variables for those that are not in the problem. I'm going to call those x and y. The last thing we need to do before we can start doing some calculations is we've got to find that angle that is at the center there. Well, all the way around a point is 360 degrees. So we're saying like all the way around that point. That degree amount gets split into the 16 triangles. So if we do 360 divided by 16, notice it gives us a fraction. If we want that as a decimal, you can go up, highlight it by hitting up, hit enter to bring it down, and then once it's down here, you can do one of two things. You can either hit Control Enter, and that'll give you the decimal form of it, or next to one of the numbers, you can put in a decimal point. It'll give you a decimal form as well. The decimal point tells the calculator to give your answer as a decimal. So that means in our picture, here, this angle is 22.5. Well, what we're going to do now is we're going to do SOHCAHTOA. Let's maybe find the x first. Here's our spelling of SOHCAHTOA. As a reminder, the O's represent opposites. The A is adjacent, which is next to but not the hypotenuse. And the H is the hypotenuse, which is across from the right angle. So from our 22.5, because we want to always start from the acute angle, we're going to work with the x and then the 20. The x is the opposite from the 22.5, and the 20 is the hypotenuse. So if we look at our SOHCAHTOA, opposite and hypotenuse is sine. So we're going to have sine of our 22.5 equals our opposite, which is x, over the hypotenuse, which is 20. We put the sine 22.5 over 1 because it's just a number, and we're going to cross multiply. 1 times x is just x. And then going the other way, we'll have 20 times sine 22.5. And we're going to leave that alone for right now. Let's go do the y now. From the 22.5, the y is next to it, but not the hypotenuse. So the y is the adjacent. And then we'll use the 20 again, which is the hypotenuse. So looking at our SOHCAHTOA, the adjacent and the hypotenuse would be cosine. So we'll have cos of the 22.5 equals our adjacent, which is y, over the hypotenuse, which is 20. We'll put the cos 22.5 over 1. And when we cross multiply, 1 times y is y, and we'll have 20 times cos 22.5. Well, now we're going to calculate our area. So our area of a triangle is 1/2 base times height. So we're going to start out with 1/2 times. Our base of our right triangle was the x. So we're just going to fill in what x was. 20 times sine 22.5. Now when we go to put this in the calculator, just note they'll have parentheses there around the sine of the 22.5. Make sure to close the parenthesis after your 22.5. Well, now we're going to do the height of that right triangle, which is our y. So here's what y was. So we'll just do 20 times cos 22.5. So this part represented the base. This part represented the height. Oops, and I am just going to throw in the parentheses here just so it'll look like it's going to look when we put it on the calculator. But right now, this gives us the area of just one triangle. We really want to find the area of the entire octagon. Well, we identified at the beginning of the problem that our octagon was 16 of those right triangles that we have drawn. So in the end, we're just going to multiply this by 16. So let's go over to the calculator and we'll type this all in. Note in the question, we're going to be rounding to the nearest hundredth in the long run. So if we go over to the calculator, I'm going to do Control Divide to get my half. Hit the right arrow to get out of the fraction. Then we'll have 20 times, hit the trig button to get sine. We'll do 22.5 and make sure to close your parenthesis. Times, our height part was the 20 times cos of 22.5. And then we have to do that times the 16 and hit enter. And now we want to round this to the hundredth, which is 2 decimal places. So look at the third spot, which we have a 0. If that third spot was 5 or higher, we'd bump the 7 up. But because 0 is less than 5, we keep the 7 the same. So we'll have 1131.37. And we had inches here, and we just did an area. So area is inches squared. All right, let's go down to the next one. This time we have a hexagon. They tell us that a side length is 8. And we're going to find the area. So let's draw in our apothem and draw in a radius, and we've got our right angle. Because of the 8, we know the apothem bisects the side, so this side is 4. To find the area of the triangle, we also need the height. So I'll call that y. Each side of this figure will have 2 of our right triangles. A hexagon is 6 sides, so if there's 6 sides, 2 triangles each side, that means we're going to have 12 triangles altogether. Again, I suggest write that somewhere in the beginning, because that'll come into our calculation later on. To find our angle at the center, we'll do 360 divided by 12. A nice way to do this in your head is ignore the 0. 36 divided by 12 is 3, and then tack the 0 back on so we get 30. So this angle here is just 30. Now note, this one's going to be a little bit less work than the last one because we had to find variables for both the base and height in question 1, whereas here we only have to find for the height. So from our 30 degrees, 4 is the opposite, and y is the adjacent. So we're going to use tangent. So we're going to have tan of 30 equals our opposite, which is 4, over our adjacent, which is y. We'll put the tan 30 over 1, and we'll cross multiply. 1 times 4 is 4, and we get y times tan 30. Y is not by itself yet, so let's divide the tan 30 over. And we'll just leave this as y equals 4 over tan 30. We'll let the calculator do the work eventually. So now let's do our area. We got to do 1/2 base times height, so we'll have 1/2 times the base of 4 times our height is that fraction of 4 over tan 30. And then times the number of triangles, which is 12. So the 4 was the base, the 4 over tan 30 was the height, and then multiply by 12 to find the area of everything. So if we go over to the calculator, we'll do control divide. We'll have 1/2 times the base of 4 times, we'll do a fraction control divide, 4 over tan of 30. Hit the right arrow a couple times to get out of the fraction. And then times the 12 triangles. And this one asks to round to the nearest hundredth again. So look at the third spot, and we have a 6. 6 is 5 and greater, so it bumps the 7 up. So we'll end up having, for our area, 166.28. 8 was a centimeters that they gave us, so this will be centimeters squared. Now you could have done this one other way. This is a 30, 60, 90 triangle. Across from 30 is D, across from the 60 is D radical 3. So this thing here really is the same as 4 square root of 3, because the D would have been 4. So that's another way you could have done it, but we're going to be rounding anyway, so you can just do it with SOHCAHTOA. All right, flipping over to the next page, a decagon is 10 sides. And we're going to pause the video for about 6 minutes to let you take this one as far as you can go. So when you're doing it, just make sure to round where they want you to round to when you get to your final answer. All right, so first we want to identify 2 triangles per side, so 20 triangles. Do 360 divided by 20 to give you 18 for the angle at the center. The apothem, the part that's perpendicular to the side, they told us was 10. Pick a variable for that base. Didn't matter which variable, I chose x. So from the 18, x was opposite, 10 was adjacent, so we have tan again. Tan 18 was equal to the opposite of x over the adjacent of 10. Cross multiply, and that got x by itself. So then when we go to our area, 1/2 the base, so the base was the 10 tan 18, times the height, and then times the 20, which is the number of triangles. When we put that in, first decimal place was a 9 in the 10th spot. We were rounding to the nearest whole, so that 9 bumps us up, so we have 325 centimeters squared. If we go to the next one, we're working with a decagon again. So we know we have 20 triangles. We also know that we can reuse that 18 degrees from the last problem. And they tell us that the perimeter is 220. The perimeter is the distance all the way around, so you can do the 220 divided by 10, and that'll give us that each side is 22. Well, if each side is 22, that means that this base is an 11. And we don't know the height, so we can call it some variable. I'm going to call it y. And we're going to pause the video for about 4 minutes and let you take it from here. Notice on this one, we are rounding to the nearest tenth. All right, we have opposite and adjacent, so we're doing tangent again. Opposite was 11, adjacent was y. That's why we have 11 over y. Cross multiply, that gives us 11 equals y tan 18. Still got to divide by tan 18 to get y by itself, so y is 11 over tan 18. So go to our area formula, 1/2 base times height. So the 11 was the base, the 11 over tan 18 was the height, and then the 20 was our number of triangles. When you put that in, we get that 3723.99 and change. We want to go to the nearest tenth, so look in the hundredth spot. The 9 is going to bump us up. So sometimes that can be tricky rounding. Think of this here as a 39. 39 would go up to 40, so that's why it ends as a 4.0. You have to have something in the tens spot when you're rounding to the tenths. And then we had inches for our units, so we have inches squared. Going over to 5, they tell us the area of this pentagon is 175. Well, let's draw in our apothem. There would be 2 triangles on each side. Pentagon is 5 sides, so that's 10 triangles. So we could do 175 divided by 10 to give us 17.5. And that would represent the area inside of this. Well, if the side length is 10, that means our base is 5. And we want to know the length of the apothem, so I'm going to call it y. So this one's different than the others because we were already given an area. So our area of a triangle we know is 1/2 base times height. We already know the area is 17.5. We know the base is 5, and the height we called y. 5 times 1/2 will give us either 5/2 or 2.5. If we divide the 2.5 over, 2.5 will go into y 7 times. And based on our units, we'll have centimeters. It's not squared because it was the length of the apothem, not an area, and a length is a one-dimensional measurement. So your homework is the next question only, so just question 6. So any time left in the period can be spent working on that question. Notice there's no units given on question 6, so when you get your area, you would just end up putting units squared on it in the long run. Have a good rest of your day, and you could be working on that homework with any time remaining.